Solution for tutorial 3 question number 1. So there is a composite wall of a oven consists of 3 materials, 2 of which are known thermal conductivity. So for material A, thermal conductivity given 20 watt per meter Kelvin. For material C, thermal conductivity given 50 watt per meter Kelvin. Also the known thickness for material A, thickness is given 0.3 meter, and for material C, thickness is given 0.15 meter. Now in the third material B is sandwiched between material A and C, is a known thickness, so you thickness for material B also given 0.15 meter, but thermal conductivity is unknown, so Kb is unknown. Okay, now the under steady state operation condition, measurement reveal the outer surface temperature is 20 degrees Celsius and inner surface temperature, so Ti, is 600 degrees Celsius. And oven air temperature, say oven air temperature T alpha is given 800 degrees Celsius. Also the oven inner convection heat coefficient given is 25 watt per meter square Kelvin. Now what is the value of Kb? So we'll find out the material B thermal conductivities. Okay, so this problem we will solve based on some assumption. First one is the steady state condition. So assumptions. Assumptions are steady state condition. Second one is the one-dimensional condition. One-dimensional conduction, and the constant properties. Also, we'll ignore the contact resistance. We'll ignore the contact resistance between material each other. So contact resistance, resistance is negligible. And another, we will ignore the heat loss due to the radiation. So radiation effect say radiation effect is negligible. Okay, so these are the given parameters and these are the assumption. So now I'll draw the thermal circuit. Say thermal okay the oven inside temperature, so T alpha, then heat will transfer through between oven air to the oven inner surface due to the convection. So convection thermal resistance will be the 1 over convection coefficient and area. Then the temperature of the oven inner surface, say oven surface temperature inner side. Then there will be the conduction, heat will flow from through the material A. So thermal resistance for material A, so length for material A over thermal conductivity for material A and the area. Okay, then the material B, thermal resistance, so length for material B, thermal conductivity for material B and the cross-section area. Then the material C, thermal resistance, so length for material C, thermal conductivity for material C and area. Then the outer surface, oven outer surface temperature. So heat will flow from oven inside to the outside direction, heat flow direction. So now we can calculate how much heat will transfer through the composite wall, say through a composite wall, heat transfer due to the conduction. So basically between this portion will be equal to temperature difference divided by total thermal resistance for through the composite wall. So here temperature difference is T oven inside temperature minus T oven outside temperature divided by total resistance for material A, thermal resistance for material B, thermal resistance for material C, thermal resistance. Now heat flux. So heat flux will be for the per unit area heat transfer. So Q through the wall divided by area. So Q value from here. So we can write down say 1 over A times Q is say T surface inner minus temperature oven surface outer, and we can write down like say L A K A 1 over K. So 1 over A, if I take the common, the area, so length for material A, then divided by thermal conductivity for material A plus length for material B, then thermal conductivity for material B plus length for C divided by thermal conductivity for C. A. So we can take common 1 over A. So this now, this A will cross out. Now if I put the all values, so it will be the heat flux. Now there is an inside temperature, inside wall temperature for oven is given much given 600 and outside is 20. Okay, so 600 minus 20 and length for material A is given 0.3 meters, so divided by thermal conductivity is given 20 plus length for B is given 0.15 and thermal conductivity for material B is unknown. We will find out this one. Material C length given 0.15 and thermal conductivity given 50. So from here we'll get the heat flux through the composite wall. It will be 580 0.018 plus 0.15 K for material B. So this one is the heat flux through the composite wall. Now we can say for here, this inside oven temperature it will transfer through from oven air to the inner wall through the convection. So here will heat flow through the convection. So convection heat transfer between oven air and the inner wall of the oven. So we can calculate the convection between the oven air and inner wall. So heat flux, so it will be a convection, so a coefficient of convection, then your oven air temperature minus inner wall temperature. So we'll get here H is given 25 and oven air temperature given 800 minus inner temperature for inner wall temperature for oven given 600. So it will be 5000 watt per meter square. So basically this heat flux will transfer through the oven air to the inner wall, then the same amount of heat transfer will transfer to the composite wall also. Say we can write down here, say from this equation, say 5000 equal to 580 0.018 plus 0.15 thermal conductivity for material B. Now if we solve this one, we'll get our required answer. So material B thermal conductivity will be 1.53 watt per meter Kelvin. Okay. Yeah, straightforward problems. Okay, now I'll solve that.